Good evening, sir.
Good evening, madam.
Good evening, sir.
Good evening, madam.
Sir, shall we start now, sir?
Sure.
Good evening, everyone. We welcome you for the day 2 of the 5 days online SPSS workshop in research. Now the session was handed over to today's resource person.
Thank you. Thank you, Dr. Sekhar sir and his team. Welcome all the beloved participants. Yesterday, we discussed about the correlation. Today's module is about regression. There is a similarity between correlation and regression. At the same time, there is a difference between correlation and regression. So what is the similarity? What is the dissimilarity? Or what is the difference? Similarity. In both of the cases, the tool is applied to examine the relationship between two or more variables. That is the dissimilarity. Similarity. What is dissimilarity? In the case of correlation, we have computed the coefficient of correlation. It is the measure of extent of relationship or degree of relationship. So to what extent the variables are related. We have learned that there is a positive correlation or negative correlation, simple correlation and multiple correlation. the degree will be, if the rho is 0, no correlation. Between 0 and 0.25 means very low degree of correlation. Between 0.25 and 0.5, low degree of correlation. Between 0.5 and 0.75, moderate degree of correlation. Between 0.75 and 0.9, high degree of correlation. Between 0.9 and 0.99, very high degree of correlation. If it is 1, we said that it is perfect correlation. So in that case, we can ascertain the degree of relationship. That's all. Whereas the regression is a forecasting tool or prediction tool. While discussing about correlation, I said there is no dependent or independent variable. The variables are interdependent. In the case of regression, once again, there is a dependent variable and independent variable. Unlike in the case of correlation, we have dependent variable and independent variable. In the case of regression. Regression also can be classified as simple regression and multiple regression. Here, the impact of independent variable on dependent variable is computed, or the influence of independent variable on dependent variable is computed. So there are dependent and independent variables. What is simple correlation, simple regression? If we take only one dependent variable and one independent variable. So there are two variables only. One is dependent variable, another is independent variable. In that case, it is said to be simple regression. If one dependent variable and two or more independent variables are there, in that case, it is said to be multiple regression. In both the cases, there is one dependent variable. If one independent variable is there, it is simple regression. If two or more independent variables are there, it is said to be multiple regression. So what is the influence or impact or effect of independent variable on the dependent variable? It is also a parametric test. If it is parametric test, obviously we understand that the dependent variable must be scale data. Okay. What about independent? Independent variable may or may not be scale data. It may be ordinal data or scale data. In the case of independent variable, it may either be scale data or it may be ordinal data. In both the cases, we can apply regression. Like the correlation, in the case of regression also, n should be equal for all the variables. Number of items should be equal. Like in the correlation, we saw that the number of students was 20, 20, 20, 20 for all the marks. The same students, of course. So 20. Here also, the number should be equal. So comparison of correlation and regression. Similarity number one. In both of the cases, the relationship between two or more variables is measured. Relationship between two or more variables is measured. Number two, the data should be scale data. Here, dependent variable should be scale data. Number two. Number three, numbers should be equal. Numbers should be equal. These are the similarities between correlation and regression. Okay. What are the dissimilarities? Dissimilarity, number one, correlation shows the degree of relationship only, whereas regression is a prediction tool, forecasting tool. For example, the values of 20 students, in this case, we shall take it. 20 students, values are given, marks are given. Based on this, if the marks obtained by 21st student, we are provided with the marks obtained by 20 students only. After distributing the papers, you find that another student is also there. Another student is also there. Then you evaluated the paper and you have calculated the marks. Marks in cost accounting. But you couldn't find the paper of income tax of that particular boy or particular student. What to do? Okay. So, value of one variable is known. Value of another variable is unknown. Value of one variable is known. Value of another variable is unknown. If value of one variable is known and another variable is unknown, the unknown value may be predicted or forecasted with the help of regression analysis. So that is the major difference between correlation and regression. Then another dissimilarity, in the case of correlation, all the variables are interdependent. Here, dependent and independent variables are there. So these are the similarities and dissimilarities between correlation and regression. So regression is basically a predicting tool or forecasting tool. It is used when one value is known and another value is unknown. So for forecasting or predicting the other value, the regression is used. Sometimes that dependent variable might have been influenced by more than one independent variable. If only one independent variable is influencing the dependent variable, we go for simple regression. If more than one variable is there, or two or more variables are there, that influences the dependent variable. Now, for example, marks obtained by students are given. If this is considered as dependent variable, time spent for preparation for exam at school or at college. So there may be a relationship between study hours and marks. Study hours and marks obtained. So here, study hours is independent variable. Marks obtained is dependent variable. We know that the marks obtained may be based on study hours. How hard you are preparing, or how much time you have spent for preparation. Sir, for the past 1 week, I have prepared for this exam, sir. What is your mark? Another boy. How long you have spent for preparation? Sir, I spent only 2 days. What is your mark? Another student. Sir, for the past 1 month, I have been preparing. What is your mark? See, look at here. Independent variable is study hours. Study hours, 4 hours, 5 hours, 6 hours, 10 hours, 10 days, 1 week, 1 month, 25 days. They are scale data. They are scale data. Okay. Sometimes you look at the question paper and find the level of difficulty. Level of difficulty. Preparation is one thing to determine the marks. Another one, as I told you, difficulty level. You are classifying or categorizing the level like very easy, easy, moderate, difficult, very difficult. Like that, you can categorize. Or simply easy, difficult, okay. Somehow, okay. This difficulty level could also influence the marks obtained. The other independent variable I told you, study hours. How much hours you have spent, or how many hours you have spent, how much time you have spent, how many days you have spent for preparation. It is collected as scale data. So independent variable in this case is scale data. Okay. The other thing I told you, difficulty level. Difficulty level also could influence the marks obtained. We are asking our students, why you have not scored good marks? He says, madam, it is very difficult, madam. The question is very tough, madam. Like that, our students are telling no. So, the marks obtained by students could also be influenced by difficulty level. So, here difficulty level is given in ordinal data. Very easy, moderate, difficult, or tough, very tough. Earlier, 10 hours, 15 hours, 20 hours, 30 hours, 50 hours. So scale data. Independent variable is scale data. Here, independent variable is ordinal data. No problem. In the case of regression, whether it is independent variable is scale data or ordinal data, it is immaterial. What is the main concern? The dependent variable must be scale data. So dependent variable must be scale data. Okay. Now, I told you, it is a measure of relationship between two or more variables. In the case of correlation, we found that A to B and B to A correlation coefficient was same. When we compare A and B or B and A, reverse comparison. In that case also, the correlation coefficient was same. Here, the variables are not interdependent. There are dependent and independent variables. There are dependent and independent variables. See here, in the example I told you, marks obtained is given in scale data. Independent variable, study hours, is also given in scale data. So both are scale data. Here we know pretty well, study hours is an independent variable. Marks obtained is dependent variable. In some other case, variable 1 and variable 2, or variable A and variable B. Okay. In that case, maybe A is independent variable and B is dependent variable. Or otherwise, A is dependent variable and B is independent variable. B is independent variable. In the correlation A to B, B to A, we got the same correlation coefficient. But here, we have to check whether it is same or not. For that, we have an equation. We have an equation that is called regression equation. Now we take the variables as X and Y. We don't know which is dependent, which is independent. There are two variables. Variable 1 is called X. Variable 2 is called Y. We have two regression equations. Regression equation of X on Y. Regression equation of Y on X. Regression equation of X on Y. Regression equation of Y on X. Most probably, we take the second one. Regression equation of Y on X. In that case, Y is called dependent variable. X is called independent variable. Y is called dependent variable. X is called independent variable. That equation is known as regression equation of Y on X. Regression equation of Y on X. What is the equation? Y equal to A plus Bx. Y equal to A plus Bx. So X is in the right hand side of equal to. On the left hand side, Y. What is given in the left hand side of equals is known as dependent variable. So here, that equation is known as regression equation of Y on X. Y equal to A plus Bx. Y is dependent variable. X is independent variable. Okay. Then what is A and B? You know, the independent variable is there, no? We cannot say the dependent variable is influenced 100% by the independent variable. 100% it cannot influence. There may be some intercept between X variable and Y variable. That is taken as constant. That intercept is known as constant. In this equation, Y equal to A plus BX. A is constant. B is coefficient of X. So here we are computing the coefficient of regression. Earlier we computed coefficient of correlation. Now we are computing coefficient of regression. That coefficient is multiplied with the X value, or X value is substituted. Then A is constant. It is added with the product of B and X value. I told you, no, regression is used to predict the unknown value. 20 values are given for both variable X and variable Y. 20 values are given. Apart from that, 21st value of X is given. We are required to calculate the 21st value of Y. So based on the 20 values of X and Y, and the 21st value of X, we have to predict the 21st value of Y. For that only, we followed the equation, regression equation of Y on X. Y equal to A plus BX. A is intercept or constant. B is coefficient of X. So if the X value is known, we substitute the values. We are going to compute A and B through regression. We are computing A and B, then substituting the value of X, solving the equation, we can predict the value of Y. Similarly, if suppose X is dependent variable and Y is independent variable.
Sir, sorry, sir. Sir,
Yeah.
your screen is not moving, sir. Same screen visible.
No, I have
Yes,
not changed
also.
it. I'm
Okay.
just explaining you.
Right, sir. Okay.
We'll start later. Yes, that concept should be explained. Is it okay, Shekhar?
Yes, sir. Okay, sir.
Okay, okay. See here. So, regression equation of X on Y. X equal to C plus dy. C plus dy. Here C is constant. D is coefficient of Y. Likewise, we can write the equation, compute the values of A and B or C and D, then substitute the value of known variable. Suppose Y on X means X value is known. X on Y means Y value is known. That is why we call regression as prediction tool. It is in the case of simple regression. Then multiple regression is. What is multiple regression? I told you, no, there are two or more independent variables. Two or more independent variables. One dependent variable. So these independent variables individually and together influence the dependent variable. These independent variables either individually or jointly together can influence the dependent variable. So what is regression equation of y on x in the case of multiple regression? Y equal to a plus b1x1 plus b2x2 plus b3x3 up to bnxn. Y equal to a plus b1x1 plus b2x2 plus b3x3 up to bnxn. So here, once again, a is constant. b1 is the coefficient of x1. x1 is the first independent variable. The next component of the equation is b2x2. b2 is the coefficient of x2 variable. x2 is the second independent variable. Any number can be there. Not only two independent variables. There may be three independent variables, four independent variables, five independent variables, and so on. So this is what simple regression and multiple regression. Regression equation of y on x and regression equation of x on y. In the case of multiple regression, regression equation of x on y will be x equal to c plus d1 y1 plus d2 y2 plus d3 y3 and so on up to dn yn. See here, one problem is given. The following marks are scored and the CGPA, cumulative grade points, obtained by MBA students of a B school in the university examination. Now, let us see how to apply simple regression. We take marks in investment management as independent variable and CGPA as dependent variable. You are required to examine whether there is any significant relationship between the marks obtained by the students in various subjects and the CGPA. Here also we can make null hypothesis and alternative hypothesis. There is no significant relationship between marks obtained and CGPA. If suppose we are considering these two only, there is no significant impact or relation between or influence of market investment management and CGPA. Or there is no significant impact of marks in investment management on. If we are using relations, then we have to use between. There is no relationship between marks in investment management and CGPA. If we are using the word influence or impact, influence of independent variable or dependent, of independent variable on dependent. Here we are taking these two variables only. Now we will go to the analyze. Go to regression. Go to linear regression. So in the menu bar, we find analyze menu. We click on that analyze menu. Drop down menu appears. In that we find regression. If we click on regression, another sub-menu appears. In that we find number of items, but the second one is linear. We take the linear regression. If we click on that, this window appears. Look at this. I told you no, in the case of regression, we have dependent and independent variables. So dependent variable CGPA. CGPA is the dependent variable. What is the dependent variable? Marks in investment management. That's all. Now we click OK. Look at here. There are two methods: entered method and removed method. Enter method and remove method. Normally, when we go for analysis, the default method is enter method. Look at here, we have entered only one independent variable. So that is entered. Suppose if we are giving more than one independent variables, any of these independent variables have been removed. But here, default method is enter method. So look at the bottom of the table. It is clearly given dependent variable is called, dependent variable is CGPA. All requested variables entered. What is the variable entered? Look at here, marks in investment management. What is the method? Enter. What is the variable removed? Nothing. So only one model is there. Only one model is there. Dependent variable is CGPA. Now you come to the model summary. R value is given. R square is given. Adjusted R square is given. Standard error of estimate. R is the correlation value. We know. R square is the regression coefficient. Regression coefficient. Or it is otherwise called as coefficient of determination. Coefficient of determination. we need not bother about the adjusted R square and standard error. Here, look at this, predictors. What are the predictors? Number one, constant, and number two, marks in investment management. We have taken only one independent variable. The independent variables are called as predictors. Here, apart from the independent variable, we have considered one more predictor is given, constant. What is constant? I said it is intercept. It is intercept. Then look at here. It is, correlation is 0.842. 80.2% positive correlation. One star is given. That means significant at 5%. Significant at 5%. 84% means above 0.75 but below 0.9. So high degree of correlation exists between these two variables. Marks in management, marks in investment management and CGPA are related to the extent of 0.842, that is 84.2%. What about R square? R square is the coefficient of determination or regression coefficient. See here, another table is given. ANOVA. ANOVA tables are given. Here regression, residual, then total. Sum of squares, degrees of freedom, mean square, F value, and significant value. Why this ANOVA is computed? I told you no. There may be two or more independent variables. Two independent variables, three independent variables, four independent variables, like that. These independent variables may individually or jointly together influence the dependent variable. ANOVA is performed to understand the influence of all the independent variables together. All the independent variables together. The next one is giving the results of individual influence of independent variables on dependent variable. In this case, we have taken only one independent. So obviously, you can see the significant value and this significant value are same. Look at here. This is influence of all the independent variables jointly or together on the dependent variable. What is the dependent variable? It is given CGPA. What are the constant and marks in investment management? I know this constant intercept. in the regression equation of y on x, y equal to a plus bx. A plus bx. A is constant. B is coefficient of x. B is coefficient of x. Apart from that, you can find the t value and significant value in the last table. So it provides coefficients. Look at the first column. Constant 1.884. 1.884. What is constant? A. So in the equation, y equal to 1.884 plus bx. 1.884 plus bx. What is b? Coefficient of x. In this table, we are given the coefficient of x. Look at here. Coefficient of x. 0.07. 0.07. That means that is the b value. Value of A is 1.884. Value of B is 0.07. So let us write the equation. Y equal to 1.884 plus 0.07x. 0.07x. That's all. So here there are two methods, enter method and remove method. In default, enter method is taken. In the given case, all requested variables are entered. One variable we have given, that is entered. So no removed variable. Then R value is given. So it is not 1 star, it is A. Okay. 0.842. So there is a positive and high degree of correlation between x and y. This R square, I told you, no, coefficient of determination. Coefficient of determination. That means the dependent variable is influenced to the extent of 70.9% by the given independent variables. I told you, no, we cannot be certain that the dependent variable is influenced 100% by independent variable. To our knowledge, we have reviewed the literature, we have consulted the experts. With the advice of our research supervisor, we are selecting the variables. This is independent, this is dependent variable. These are independent variables. Based on literature review, based on expert opinion, based on research supervisor advice, we have taken the independent variables. But sometimes, apart from the independent variables considered in our study, what variables we have taken as independent variables? They are just illustrative. They are not exhaustive. We cannot say only these are the independent variables. We cannot say. Apart from the independent variables we have considered, there may be one or more or some other independent variables that could also influence the dependent variable. In the previous example, I told you no, marks obtained is dependent variable. Study hours is an independent variable. Difficulty level is another independent variable. We have considered only two independent variables. But why not? There may be some other variables, no? Study at home. Study at home. That is also an independent variable. That may also be an independent. But we have not considered that. So here, R square is 0.709. Otherwise, in terms of percentage, we can say 70.9%. That means the independent variables we have considered have influenced the dependent variable to the extent of 70.9%. It means the dependent variable might have been influenced by some other variables apart from the independent variables we have considered. So, enter method, all variables are entered. Correlation coefficient 84.2%, 0.842. R square is the coefficient of determination, 0.709. Then in the case of ANOVA, significance level is 0.000, so significant at 1%. In the last table, we find a constant value is 1.884. Coefficient of X is 0.07. Here also significant value is same as given in ANOVA because we have considered only one independent. So what is the regression equation? Y equal to 1.884 plus 0.07x. That's all. This is what about simple regression. Now, let us go to the multiple regression. In this case, marks obtained the same what we have discussed in the correlation in the yesterday's class. All marks are given. Then CGPA is computed. Cumulative point. Now the question is whether there is any significant relationship between marks obtained by the students in various subjects and CGPA. I have already shown the hypothesis. Null hypothesis, as usual, there is no significant relationship between marks obtained by the students in various subjects and the CGPA. Similarly, there is no significant relationship. There is a significant relationship. Of alternative process. Or otherwise, you can write like this. There is no significant impact of marks obtained by the students in various subjects on the CGPA. There exists no significant influence of marks obtained by the students in various subjects on the CG. Another format, that's all. So why different format is given is, in your thesis, you would have formulated so many hypotheses. So each hypothesis may be formulated or written in different ways in order to avoid the monotonousness. So this is called null hypothesis. Now we will go to the data analysis. The procedure are go to analyze, to regression, select linear. CGPA is the dependent variable. Marks obtained in different subjects are independent variables. Now click OK. Again, 4 tables are given. The first table, variables entered are removed. Look at here, marks in investment management, marks in cost accounting, marks in research methodology, marks in supply chain management, marks in income tax. All requested variables are entered. The method is enter method. Dependent variable is CGP. CG. Now come to the model summary. Now look at the R value, 0.956. Earlier we had only one independent variable. In that case, the relationship was 84.2%. But here it is 95.6%. What is the coefficient of determination in the previous case? Sorry. 0.709. That is the independent variables together influence the dependent variable to the extent of 70.9%. So only one variable is considered that itself has influenced to the extent of 70.9%. Now we are taking 5 independent variables. So obviously the degree, the coefficient of determination may be little higher. See here, it is 0.91. That means the predictors, 5 independent variables, have jointly influenced the CGPA to the extent of 91.3%. 91.3%. Because R square value is 0.913. Look at the predictors. Apart from 5 marks, constant is also included. Now come to the ANOVA table. In the ANOVA, look at the P value. Once again, it is 0.000. Significant value is 0.000. That means these 5 variables together have significantly influenced the CGPA at 1% level. So this measure is computed to understand the joint influence. The next table is used to understand the individual influence. Individual influence. Now come to the coefficient values. First one constant, 0.648. 0.648. Look at here. The same thing I have copied and pasted here. 0.648 constant. Then marks in cost accounting, 0.019. That is B1. Then B2. Look at here, minus. So there is a negative influence. Maybe the influence may be positive or negative. So here it is negatively influenced by marks in income tax. Similarly, marks in supply chain management. See, this is just given to understand. Don't think logically, sir, how can it influence the CGPA in negative sense? Please don't think of that. This is just a model sum. Okay. That too, to make you aware that some variables may influence positively and some other variables may influence negative. You have to make yourself clear that the impact of independent variables may either be positive or be negative. For that only these values are. Then come to marks in research methodology, positive, 0.036. Marks in investment management, that is B5. This is B1, this is A. 0.648 is A. 0.019 is B1. Minus 0.004 is B2. Minus, again the same value, minus 0.004 B3 plus 0.036 B4 plus 0.041 B5. Now you come to the P value or significant value. First one, significant at 1%. Because P value is 0.035. It is less than 0.05. If it is less than 0.05, we say that it is significant at 5%. Second one, 0.652. So there is no significance. Third one, 0.699, greater than 0.05. It is also not significant. Then the fourth one, 0.004. It is less than 0.01. Significant at 1%. Next one, 0.003. It is also less than 0.01. So it is also significant at 1%. Okay. So first one, significant at 5%. Second one, not significant. Third one, not significant. Fourth one significant at 5%. Fifth one significant at 5%. Now we compare. Compare the B1, B2, B3, B4, B5 and the P values. Look at the P value. 0.652 and 0.699 are greater than 0.05. So we call it as not significant. When we compare the coefficient of x2 and x3, we find that it is negative. So x1 is influencing positively at 5% level. X2 negatively influencing, and the influence is not significant. X3 is also influencing negatively. It is also not significant. Fourth one, positive influence, significant at 5%, 1%. Fifth one, positive influence and significant at 1%. Look at the P values. Which is the lowest value? 0.003 is the lowest value. Look at the B values. 0.041 is the highest value. Then second one, 0.004. Here it is 0.036. Then 0.035. Here it is 0.019. 0.652 negative. 0.699 negative. So in this case, we understand as the P value decreases, the influence increases. As the P value decreases, the coefficient of independent variables increases. That's it. So come to the equation. CGPA is equal to 0.648. What is 648? Constant. That is A value. What is the equation? Y equal to A plus Bx1 plus B1x1 plus B2x2 plus B3x3 plus B4x4 plus B5x5. In this case, instead of x, m is used because it is marks. So definition is given. M1 is mark obtained in cost account. M2 is marks obtained in income tax. M3 is marks obtained in supply chain management. M4 is marks obtained in research methodology. M5 is marks obtained in investment management. So what is constant? 0.648. Now we will substitute the values of B1, B2, B3, B4 and B5. 2 are negative. B2 and B3 are negative. So the equation is modified. Constant, first one A. A is 0.648. It is positive. Suppose if it is negative, you put it at the end. If it is positive, A is put in the beginning of the equation. Suppose if A is negative, then you can put it at the end. Okay. A is positive, 0.648. So A value is substituted. Then what is B1? 0.019. So plus, look at here, plus 0.019 M1 instead of X1, we have changed it as M1. The second one, minus 0.004. So in the equation, we put minus symbol. Instead of plus symbol, we are putting minus symbol. So minus 0.004 M2. What is B3? It is also minus 0.004. Again, we are putting minus symbol. Minus 0.004 M3. Then what is B4? Positive. 0.036. So we put plus symbol. Plus 0.036 M4. What is B5? 0.041. So the equation is plus 0.041 M5. That's all. So here, the CGPA is influenced by the selected independent variables to the extent of 91.3%. So there are remaining 8.7% of CGPA may be influenced by other variables that we have not considered in our study. Sometimes the R value, R square value may be very less. For example, it is 0.13. Just for example, 0.13. What does it mean? The dependent variable is influenced by the selected independent variables only to the extent of the 10%. So the remaining 87% of the CGPA is influenced by other variables. You just see what we have taken have not even influenced at least 50%. So if it is 70%, it is good. If the R square value is 0.7, it is good. If it is more than 0.7, it is great. If the R square is like this, the variables we have selected are not appropriate. We have not selected a proper variables. That is what we can understand. So here we understand that 5 variables we have taken. They are called predictors. These predictors have influenced the dependent variable CGPA to the extent of 91.3%. So the variables we have selected are good. You have done a wonderful job. Only 8.7% of the CGPA is influenced by some other variables. That's all. So once again, repeat, enter method, all the variables are entered, dependent variable CGPA, model summary says that correlation coefficient is 0.956 and determination, coefficient of determination is 0.913. ANOVA says 0.000. ANOVA says significant value is 0.000, significant at 1%. The independent variables jointly influencing the dependent variable at 1% significant level. When we come to the individual influence, we find, see, first variable influence at 5%. Second variable not influencing, not significant. Third variable not significant. Fourth variable significant at 1%. Fifth variable significant at 1%. But altogether, all the variable means they are influencing at a significant level. That's all. This is another example of multiple correlation. Then one more example I have given you, the last one. Look at here. From the following information, ascertain the influence made by price, quality, and availability on the satisfaction of consumers. So influence made by price, quality, and availability. That means these are independent variables. Price, quality, and availability are independent variables. Satisfaction is dependent variable. Satisfaction is dependent variable. So satisfaction is arrived by giving number of items. For example, satisfaction on service, satisfaction on performance, satisfaction on durability. Like that, some items are given and we have obtained the overall satisfaction score. So that is the dependent variable. The dependent variable is given as scale data. Here, independent variables are price, quality, and availability. They are given as ordinal data. Look at this. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. So it is ordinal data. In the previous one, we had scale data. All the independent variables were scale data, including the dependent variable. Dependent variable is also scale data. That must be scale data. Here, the dependent variable alone is scale data. These are given as ordinal data. That is what I told you earlier. The independent variables may be either scale data like this or ordinal data like this. Okay. So from the following information, ascertain the influence. What is the null hypothesis? There is no significant influence. There is no significant influence. null hypothesis there is no significant impact of price, quality, and availability on satisfaction of consumers. What is alternative hypothesis? There is a significant impact of price, quality, and availability on satisfaction of consumers. Okay. So there are 3 independent variables and 1 dependent variable. Dependent variable is given in scale data. These independent variables are given in ordinal data. In both of the cases, that is, either independent variables are scale data or independent variables are ordinal data. That is immaterial. What is important? The dependent variable must be scale data. That's all. Now we have formulated the hypothesis. Okay. So here we go for analysis. Analyze regression, linear regression. What is the dependent variable? Overall satisfaction. Price is an independent variable. Quality is an independent variable. And availability is another independent variable. So click OK. Or once again, let me show this. See here, third is selected as enter in default. See here, stepwise, remove, backward, forward. So there are different methods. Each method has different results. Most probably, the researchers are using enter method. So we have also taken enter method. That is why the result says that enter method is used. Here, what is dependent variable? Satisfaction. What are the predictors? All the requested variables are entered. What are the predictors? Constant, availability, price, and quality. So we don't bother. All the variables are entered. No issues. Look at the R value. R is the correlation coefficient, 0.925. That means there is a significant, there is a relationship between independent variables and dependent variable to the extent of 92.5%. These independent variables together influence the dependent variable to the extent of 85.5%, because R square value is 0.855. That means the independent variables, that is price, quality, and availability, they are influencing the satisfaction to the extent of 85.5%. So obviously, the remaining 14.5% satisfaction is influenced by other variables that are not considered in our study. Then come to the ANOVA. ANOVA. What is significant value? 0.000. Significant at 1%. The joint influence is significant. The joint influence of price, quality, and availability on satisfaction is significant at 1%. Okay. Now we come to the individual influence or individual impact. This is also given to make you aware of different situations. Don't think logically. Look at the constant 14.291. 14.291. What is B1? 0.267. What is B2? 3.384. What is B3? Minus 1.953. So we have considered three variables. Three are having different nature, different impact on the dependent variable. Price is here. Look at the p-value, 0.73. Look at here. Constant 14.21. Now look at here. Constant 14.21. That is the value of A. A is 14.21. B1 is 0.267. B2 is greater. B3 is negative. B3 is negative. Look at here. P values. For X1, it is 0.713. 0.713 means greater than 0.05. So it is not significant. Second one, that is for quality, the p-value is 0.001. It is less than 0.01. So it is significant at 1%. Third one, availability, 0.00022. That is less than 0.05. So it is significant at 5%. But understand, it is negatively impacting, but significant. First one, positive impact but not significant. Positive impact but not significant. Second one, positive and significant impact. Third one, significant but negative. Significant but negative. So in your study, there may be different kinds of results like this. Every time we cannot say that all the variables are positively influencing. All the significantly influencing variables must have positive coefficient. That need not be. That question is now deleted, because look at the third one, it is significant, but the impact is negative. Second one, positive and significant. First one, positive but not significant. So together, these three variables are influencing the overall satisfaction to the extent of 85.5%. 85.5%. R value 0.925. That is the relationship between availability, price, and quality with the satisfaction is 92.5%. Coefficient of determination is 0.855. That means the satisfaction of consumers is determined by availability, price, and quality to the extent of 85.5%. So these are the determinants. These are the determinants of satisfaction. This is model 1. Sometimes there may be more than one model. So we can select any one model based on the result. So it implies that there are some other independent variables that could influence to the extent of 14.5%. That's all. So this is another method of regression. So now let us have a recap. Regression is a forecasting tool. It has some similarities and dissimilarities with the correlation. What are the similarities? Both are used to measure the relationship between two or more variables. That is one similarity. Another one, the data are scale data. In the case of correlation, all the data are scale data. In the case of regression, dependent variable is scale data. And another similarity, numbers should be equal. In all the cases, numbers are equal. What are the dissimilarities? Number one, the dissimilarity between correlation and regression. In the case of correlation, we can find the extent of relationship only. But in the case of regression, we can predict the unknown value with the help of known value, or with the help of known value of one variable. So that is similarity. In the case of correlation, the variables are interdependent. Here, once again, dependent and independent variables. In the case of simple regression, only one dependent variable and one independent variable. In the case of multiple regression, there may be more than one independent variable. Then another point we have to note it. The independence variables may either be scale data or ordinal data. So the output is given in 4 tables. Output is given in 4 tables. First one, method. First one shows method and variables entered. It is also given in the footnote or bottom of the table what is the dependent variable. What are the variables entered? That is also shown. Then second one, model summary. In the case of model summary, 2 important measures are displayed. One is correlation coefficient, another is coefficient of determination. Correlation coefficient I'm sorry. Correlation coefficient shows the degree of relationship between independent variables and dependent variables. R square is the coefficient of determination. It shows the extent to which the dependent variable is determined by the independent variables. Very sorry. Then the third table is ANOVA. ANOVA shows the level of significance of the independent variables jointly on the dependent variable. Then individual influence is given in the last table, that is coefficient. So in this, we have coefficients and p-values. So these values denote that there may be positive and significant impact, negative and not significant impact. Here, in the next case, we found that positive but not significant impact, positive and significant impact, negative but significant. So the results may be either of these cases. That is what we have to test. So that's all about the regression and simple regression and multiple regression. Now it is the time for you to ask any questions. Thank you very much.
Professor, this is Kannan from Madurai.
Yes, sir. Yes, sir, please.
Good evening, Professor. Your presentation is wonderful, very simple, straightforward. Even any person can easily follow, though the person knows statistics or not. You are putting it very simple, straightforward. My appreciation to you, sir. Number one.
Thank you.
In
Thank you.
spite of your little ill health, you are not feeling well, but then
Yes.
you are committed to this profession. I really appreciate. I bow
Thank you.
down to you, sir. All the very best.
Thank you.
One
Thank you.
thing that I have learned today is that so far I thought only the metric variables or scale variables should be there for both independent and dependent. It's a news to me that in independent variable, ordinal variable can also be there. It's a news to me. I'm so thankful to you. All the very best and very eagerly waiting for another 3 days to come, sir. Take care. We love you, sir. And
Thank you. Thank you.
special appreciation to Dr. Shekhar, organizers.
Thank you. Thank you. Thank you.
Sir,
Madam.
good evening, sir. Am I audible?
Yes, madam. Yes.
First of all, good evening, sir. Thank you so much for this amazing presentation. Many of my doubts are cleared. Sir, I don't have any question, but I have a request. Can we get PPTs for yesterday's presentation and today's?
Yes,
it will,
madam.
yes, it will be very great for all of us that we can learn again.
Sure, ma'am. Sure.
Thank you, sir. Thanks a lot. Please take care. Thanks a lot.
Thank you, madam. Thank you.
Sir,
Good
I have
evening,
a question.
Good evening, madam.
Sir, I have doubt about when you said, the regression analysis, you told that, sir,
Yes, madam,
number,
please. Yes, you are audible.
what is the meaning of number should be equal? Are you talking about n is equal to some equal number?
Yes, yes. N should be equal for all the variables. Yes.
For all the variables, n should be equal.
Yes, yes, madam.
Okay. Fine, sir.
Thank you.
And whenever we are doing the regression test, sir,
Yes, madam.
depending upon the data that we have collected, for example, if we have collected some data on remuneration and there is some data on motivation, remuneration
Any
and
data you
motivation
can take.
goes hand in hand.
Madam?
Sir, remuneration and motivation are independent, right? Dependent variables, right, sir?
If you are comparing remuneration and motivation, remuneration is independent and motivation is dependent.
Remuneration is independent, okay?
Yes.
And motivation
And
is dependent.
the motivation is dependent because if you are paying more remuneration, they will be more satisfied. No.
True, sir. True, sir. Thank you, sir. It was a very wonderful session. And you have so much of knowledge, which you are sharing it to everybody. Thanks a lot, sir.
Thank you. Thank you.
And sir, can we get your number so that, if we have any doubt when we are...
Yes, ma'am. Sure, sure.
Good evening, sir. This is Giridhar. Just have a small question. That is, I think there's a cross connection. Sir, my question is that does this software also give the graphical representation of this?
Graphical representation is also can be made.
Okay. No, does the software give us direct output or it has to be computed or it has to be prepared manually?
From SPSS, you can draw the graph or using Excel also you can draw the graph.
Okay, fine.
Yes.
Right.
Thank you.
So I have
Good evening,
another
sir.
input to give on the same question.
Yes, madam.
Sir, when you are collecting a Google form, generally the questionnaires will be collected in Google form.
Yes.
When the same thing is extracted in an Excel sheet, the Excel sheet itself will give you the graphs.
Yes, yes. From Excel sheet itself, if suppose you are collecting in Google form,
yes,
that Google form itself will be giving you the graph also.
Yes, sir.
Yes.
Thank you, sir.
Good evening, sir. Good evening,
Good
sir.
evening,
I
ma'am.
need a small clarification, sir. If
Yes,
this
ma'am.
regression equation, second table or ANOVA table, we'll get F value. how to interpret what is the significance of that F value and how to interpret that F value.
Madam, for all the tests of hypothesis, the most important item is P value. That is probability value. In the case of P value as F value as you are asked, if you have asked, let me show this once again. Here, sum of squares, regression and residual.
Yes, sir.
Usually in the ANOVA, we will be having the sum of squares means between groups and within groups. Then sum of squares, degrees of freedom, mean square and F value. Now look at this. Sum of square. What is the sum of square for the first one? That is regression 108.475. Then what is degrees of freedom? 3. If you divide 108.475 by 3, you will be getting the mean square.
Okay.
That is 36.158.
Okay.
Similarly, 18.325 divided by 16,
16.
you will be getting 1.145.
Okay.
F value is considered by dividing, it is computed by dividing 36.158 divided by 1.145.
Okay.
Yeah.
Okay.
See here, I told you 1.108.475 divided by 3. What is the answer? 36.158. Okay. Then the other one, 18.325. 18.325 divided by 16 comes to 1.145.
Yes, sir.
So that is the mean square of the second one. Now 36.145.
158.
Sorry, 158. Sorry. 158 divided by 1.145.
Yes, sir.
Look at the value, 31.571.
9.
That's all. 9. Okay. Maybe it is a rounding
Error
of
may be there. Okay.
mechanism. That's all.
Okay. Thank you.
So
Thank
this
you
is
very
how
much,
F value is computed.
sir. Okay. Thank you very much, sir.
Okay. Thank you. Any other doubt?
Thank you, sir. Thank you for your wonderful presentation.
Thank you. Thank you, sir.
Thank you, one and all. Next, we will see in the third day of the session.
Tomorrow
share your
we will
number,
be
sir.
discussing ANOVA and MANOVA. Third day module is ANOVA and Manova. Then fourth day, Ankova and Mankova. Fifth day, cluster analysis. Okay. Thank you very much. Thank you all the participants and Dr. Sekhar and his team.
Please repeat the fifth
Thank you, sir.
Sir, thank you,
Madam,
sir, for presentation,
fifth day
sir.
cluster analysis, madam.
Thank you, sir.
Thank you so much, sir.
Thank you, madam. Thank you.
Sir, thank you so much, sir.
Thank you, sir.
Thank you so much, sir.
Thank you, madam.
Thank you so much, sir.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you,
sir.
Thank you, madam. Thank you.
So please, can you share the number?
Yeah, putting in the
Sir.
chat box.
So please share the PPT.
Oh, yes, sir. Yes, sir. I didn't have present the PPT.
Yeah.
Anyhow, I will share.
Okay. Sir. Thank you, sir.
We have I given my number.
Thank you, sir.
9860. Okay, thank you. Thank you. Welcome. Sekhar, make it.
Okay, sir.
Thank you. Thank you, dear friends. Good night.
Thank you, sir.